Today's topic is the modulus functions. First, I'll define the modulus. Modulus can also be regarded as the absolute value. The modulus of x written as x with two vertical within two vertical lines, written as modulus of x is defined as, so modulus of x is equal to x when x is greater than or equals to 0, and modulus of x is equal to minus f if x is a negative number. So let us discuss this thing. What is meant by this definition? If x is a positive number, if x is a positive, let us take an example. X a positive number. So example, if I take a number x is equals to 2, for example, a positive number. So when you use this definition, modulus of x is equals to, so I'm using the value of x here. So 2 modulus is equals to 2. These two are the same. And if x is a negative number, for example, minus 2, then using the definition that x is equal to minus x for negative values. So minus 2 is equals to minus 2 into minus 2. So minus 2, modulus of minus 2 is equals to 2. So the other definition of the modulus can be the modulus of x is the distance of x from 0 on the number line. So if I draw a number line, 0 is here on the number line. The same example, the modulus of 2. So what is the distance of 2 from 0? So this is 2. So the answer is 2. Minus 2 is on the left hand side of the of 0. So the minus 2. So if I ask you what is the distance of minus 2, the distance of minus 2 from 0, so the distance is 2 again. So write the modulus of minus 2 is as 2. So it means that if in these two vertical lines, whether we have plus sign or a minus sign, that is plus. So I can write a note here. The note is the modulus of any number whether positive or negative, is always a positive. So here the modulus of 2 is 2, the modulus of minus 2 is 2, and this is basically the distance of x from the, so this is 2, the distance of x from 0. So if you have a number line, the distance of 2 from 0 is 2, and the distance of minus 2 from 0 is again 2. So plus minus 2 modulus is always equals to 2, and keep in mind this note that the modulus of a number, a positive or a negative, is always a positive number. So the modulus uh, of a number is also called the absolute value. So I can write based on this basic information that if I write modulus of x is equal to 2, So what are the possible values of x? So clearly from the previous discussion, I can say that this x can be plus 2 or minus 2. So keeping in mind that modulus of x, when we remove the modulus, we always write plus minus 2 on the other side. For example, uh, if I write a question that solve 4x minus 3 modulus is equal to 7. So solution. So in this case, we have to state the possible values of x. So bearing in mind this basic information that when we remove the modulus sign, we write plus minus because these are the possible values of this x. So plus 2 or minus 2 in this example. So what are the possible values of this whole thing? So I can say that the possible values of 4x minus 3, if as a whole 4x minus 3 is plus 7, the answer is 7. If it is minus 7, the answer is 7. So there are two possibilities, plus 7 or minus 7. Plus 7, minus 7. So when we remove this modulus sign, these two vertical lines, so we write plus minus with the number. So 4x minus 3 is equals to 7 is one possibility, and 4x minus 3 is equals to minus 7 is the other case. So we have two linear equations. You can solve them uh, simultaneously. So 10 over 4 means x is equals to 5 over 2, and 4x is equals to minus 4x is equal to minus 1. So after obtaining these values, so the given equation was the modulus equation. So this is basically the topic, the modulus equations. The modulus equations. A simple case of the modulus equation. So when I remove these two vertical lines, I wrote plus minus on the other side. In this way, there are two linear equations. You can solve them for the values of x. So always check the answer. So check the answer whether these answers are okay for the given equation or not. That given equation is the modulus equation. So let us take x is equals to 5 over 2 in the given equation, this equation, 4x minus 3. So check what is 4x minus 3. Is it 7? So let us verify. 4 into 5 over 2 minus 3 modulus is equal to uh, 7. And just so we have 10 minus 7 modulus is equals to 7 means 7 is equals to 7. So this is true. So the answer is correct. The other answer was x is equals to minus 1. Let us verify in the given equation 4x minus 3 modulus is equals to 7. So 4x minus 3 modulus is equals to 7. 4 into minus 1 minus 3 is equals to, we're just trying to check whether it's okay or not. So this is minus 4 minus 3 is equals to 7. Minus 7 is equals to 7. And yes, we know that minus 7 modulus is 7 is equals to 7. Again, this is true. So this is true, this is true. So both answers which we obtained from these two linear equations are satisfying the given modulus equation, and hence after checking, after verifying, you can write the answers as the answers for this question, that either x is equals to 5 upon 2 or x is equals to minus 1. So these are the answer to this question. So remove the modulus sign and write plus minus and check in the end in the given uh, equation. Second question is, so a different question. Question I'm writing here. Solve 3x. This is again modulus equation. 3x plus 4 modulus is equals to x plus 5. So what is the technique? There are different methods, but the shortest approach is that you remove the modulus sign, and keeping in mind that we are handling the modulus thing. So remove the modulus and write plus minus on either side. So either on the left hand side or on the right hand side. Don't write plus minus on both ends, so on either side. Right hand side I'm writing plus minus. Next, make two cases of linear equations. 3x plus 4 is equals to 1 is x plus 5, and other case is 3x plus 4 is equals to minus bracket x plus 5. So simplify. 3x minus x is equals to 5 minus 4, and 2x is equals to 1. X is equals to 1 over 2 is the answer coming from this end. And 3x plus 4 is equals to minus x minus 5. 3x plus x is equals to minus 5 minus 4. Simple solution. 4x is equals to minus 9 and x is equals to minus 9 upon 4. So don't leave your answer here, but we need to check. Check where in the given. This is a given equation. Check in one. So um, find whether the two sides are equal or not by using x equals to 1 over 2. So I'm verifying. So x equals to 1 over 2, 3x plus 4 is equal to x plus 5. So you can find the answer for the left hand side and the right side separately, or you can follow this pattern that just write question mark here, whether we are verifying whether we are checking whether these two sides are equal or not. So 3 into 1 over 2 plus 4 modulus is equals to 1 over 2 plus 5 is equals to 3 over 2 plus 4 is equals to, you can simplify. So the answer is 11 over 2. 11 over 2 modulus is equals to 11 over 2. And yes, 11 over 2 is equals to 11 over 2. So this is true. If this is true, then you can say, so this is okay. So answer, you can highlight, this is one answer. So the other was minus 9 over 4. So we'll write this as final answer after verifying. So x is equals to minus 9 over 4. I'm verifying in the given equation number 1. So equation 1 implies 3x plus 4 is equals to x plus 5. So 3 into minus 9 over 4 plus 4 is equals to, because these are for sure the answer for the linear equation. These are the linear equations, but the given equation was modulus. So we need to verify in the given. So answer is uh, here on the right hand side, minus 9 over 4 plus 5 minus 27 over 4 plus 4 is equal to 20. So the right hand side is giving you minus 27 4 plus 4, which is 11 over 4 minus 11 over 4 modulus is equals to 11 over 4. And we know through the definition that 11 over 4 modulus is 11 over 4. 11 over 4 is equals to 11 over 4. Again, this is true. So if this is true, so highlight this thing. This is the answer, minus 9 over 4. So the answers are, for this question, the answers are x is equals to 1 over 2 and minus 9 upon 4. These are the two answers. So first write plus minus, solve simple linear equations, and don't forget to apply this step in which we verify. So always verify before writing the final answers. Another example is solve uh, 8 minus 1 minus 2x is equal to x. Solution. 8 minus 1 minus 2x is equals to x is the question. So here you write, first of all, simplify. 8 minus x is equals to, try to bring the modulus on one side. So it was 8 minus modulus. So you can write just modulus on one side by shifting the terms 8 minus x is equals to, so, or you can write 1 minus 2x modulus on the left hand side. It's the same thing. As this is the modulus equation, this is the equation involving modulus. So how to solve this modulus equation in which one side is containing the modulus, the other is not. One side is the modulus, the other is linear. So the technique is simple. The technique is simple and the same as before. You remove the modulus by writing plus minus on either side. 1 minus 2x is equals to 8 minus x. You can write plus minus on the left hand side or on the right hand side, doesn't make any difference. So 1 minus 2x is equals to 8 minus x is one case, and 1 minus 2x is equals to minus bracket 8 minus, 8 minus x is the other case. So simplify, 1 minus 8 is equals to minus x plus 2x. So minus 7 is equals to x. So x equals to minus 7 is one answer. 1 minus 2x equals to minus 8 plus x. 1 plus 8 is equals to x plus 2x. So we have 9 is equals to 3x, or x is equals to 3. These are the two values of x. These are the answer for these two linear equations. So we need to verify them in the given, either here, or here. So on any one side, in any one equation, you can verify. So let us check. But let us check, or let us verification. This is a verification step. So don't forget to apply this step for the modulus equation. So let us start with, so I'm using this form. Check x equals to minus 7. X equals to minus 7 here. Check in one. So 8 minus 7 is equals to modulus 1 minus 2 into minus 7. I'm just verifying. 8 plus 7 is equals to 1 plus 14. So left hand side is 15 and right hand side is 15 modulus. And we know that 15 modulus is 15. So this is true. This is true. So accept this answer. Yes, the one answer is x equals to minus 7. Let us verify the other, which is 3 in the given equation. So 3 in the given equation. So when I use this 3 in the given equation, x is equals to 3. In one implies 8 minus 3 is equal to 8 minus 3 is equal to uh, 8 minus 3 is equals to modulus 1 minus 2 into 3. 5 is equals to minus 5 modulus. So here we have the answer. 5 is equals to 5, which is true. Hence, the other answer is here. Next, I'll take a case in which the verification will give you a different situation. So the answers are x is equals to minus 7 and x equals to 3. These are the two answers, 3 and minus 7. Another case, solve 1 minus 2x modulus is equals to x minus 8. So we have the solution here. 1 minus 2x is equals to plus minus x minus 8. 1 minus 2x is equals to 8 minus x. 1 minus 2x is equals to minus bracket 8 x minus 8. And then 1 minus 2x, you can solve it for x. So here I can write 1 plus 8 is equals to x plus 2x, x plus 2x. So 9 is equals to 3x, x is equals to 3. And 1 minus 2x is equal to minus x plus 8. 1 minus 2x We can simplify for x as 1 minus 8 is equals to minus x plus 2x minus 7 is equals to x. So let us check these in the given equation, where in the given equation, check in 1, x is equals to 3, then 1 implies 1 minus 2 into 3 modulus is equals to 3 minus 8, 1 minus 6, 1 minus 6 is equals to minus 5. Minus 5 modulus is equals to minus 5. This is 5 equals to minus 5. So this is false. So 5 cannot be, so this cannot be the answer. So x equals to minus 7, verify in the given equation. 1 minus 2 into minus 7 modulus is equals to x minus 8. So x is minus 7 minus 8. 1 plus 14 modulus is equals to minus 15. 15 modulus is minus 15. By the definition, 15 modulus is 15 is equals to minus 15. Again, we're getting a wrong thing, like 15 cannot be equal to 15 cannot be equal to 50 is not equal to minus 15, so this is a false thing, so this cannot be the answer. So here, what is the answer for this question? So I can write there is no solution for this. There is no solution because you can't find a value for which this equation is true. So no solution is the answer for this question. Next, in the next lecture, I'll discuss the modulus inequalities. Okay, subscribe my channel and click bell icon for more videos. Thank you.